Hello, good day. This is PokeParadox again. Now for tutorial 3 video. Hopefully we'll get some code up and running in Penjin. So first things first, we actually want to get hold of the Penjin source code. So here's the URL, the public URL for the Penjin source code. You can get that at code.google.com/p/penjin/source/checkout, and that will give you the public link for the repo. If you like the command line, you can just simply type this here, and that will use the SVN in Ubuntu, the SVN program in Ubuntu, to check out the source. But we're trying to make this, straightforward. So, if you've ever used Tortoise SVN, we have something similar that we can use in Ubuntu. This is RabbitVCS, and again, you can, if you go to RabbitVCS.org. There you go. Easy version control for Linux. Get it here. So if you click the Ubuntu logo there, and that brings you to this page that I was on. So first things first, we need to add the PPA. This is like the installation source address, if you like. This is how Ubuntu and a lot of Linux distributions work. You can add sort of a well, it's called a repository as well, and this lets you install different programs from third-party sources. So we copy this here, and we need a terminal. So if you go to your launcher there, more apps, and terminal. If you don't see terminal there, then just type in term. And there you go, you've got terminal server client, which is something else, and terminal. So run the terminal, right click and paste that, sudo add apt repository ppa :rabbitVCS/ppa, and hit enter. It'll ask you for the password. Password, by now you should know, is Penjin, if you've been following the tutorials in order. And so there you go, that's added the RabbitVCS repo. In my case, I already had the authorization key set up, so that's why it's saying unchanged. But in any case, you should have the repo added here as well now. Okay, so with the repo added, then we should actually install RabbitVCS. So if we go to if it stops messing about, if we go to the main menu, applications, Synaptic, you can type SYN to find it in the search box. If it doesn't appear there, type in the password Penjin. Okay, and yeah, we'll need to reload the packages. With the repos refreshed, we can actually add RabbitVCS. So if you type in Rabbit VC, there we go. So there's various components, but we want the Nautilus version. So just mark that for installation there, and mark that, and just hit apply. Okay, and hit apply. So that's installing right there. And changes have been applied. Good, just what we want. So close out of that. Okay, so with RabbitVCS installed, for the Nautilus component, we do actually have to restart so that that will start working. So let's restart. Okay. And restart. The next port of call is we're going to check out the Penjin source code. So whenever you're ready, computer, come back. Whenever you're ready. Do 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 do. Hello. So yeah, with the computer restarted, we need to check out the source code. So if we go to the home folder, Penjin, documents, programming, and here we can create new folder, and you can see the RabbitVCS menus have been added, and they should be working. But let's create a new folder. Create folder, call it Penjin. Okay. In this folder, create another folder called Penjin base, as so. Okay, and here's where we're going to check out our Penjin source code. So if you right click that and go to RabbitVCS SVN, click checkout. We need to put the URL of the Penjin source code repository in this box. So it's lost the page that I was on. So yeah, if you go google.com/p/Penjin, click source, and copy this address here, include all the way over to the trunk / copy that and paste that in this URL box. Okay, and just check this directory is going to the right place, Penjin base, that's fine, and hit OK. And hopefully, yeah, you can see it's checking out all the files that we need to get. So just hit OK, and a nice green tick appears. So that means we're up to date with the repo. Okay. So welcome back. So you should have a RabbitVCS installed. You should have just checked out the Penjin source code, to documents, programming, Penjin base with a nice green tick showing that you've got all the latest Penjin source code. Okay, so the next part of this tutorial is we need to start our own example project. So if we create another folder called example, righto, and let's run code blocks. So there you go, code blocks IDE. You can search for that if it doesn't appear there, but it should do. Here we go. Okay, so within code blocks, before we get started, we need to go to up here, settings, global variables, and you want to create this Penjin variable here. So let me just, well, we'll just get rid of that there, and we'll delete that there. Okay, so you'll start off with a screen like this, nothing there at all, and in the default set you want to create new, call that Penjin. Okay, and you just need to point it to the Penjin base directory, so that will be in documents, programming, Penjin base, and hit open. And that's it, just close that there, and that's the global variable set up for Penjin. Right, the next port of call is we want to create a new project, so if you click that there, we're just going to create an empty project, so hit go, project title, example, folder to create project in the example folder, example CPP, that's the project file, and yeah, that's a bit overkill, so you want to edit this back so that, there you go, Penjin example CPP. Okay, so hit next. The compiler we want to use is Linux, and yes, create a debug configuration and a release configuration, so hit finish, and you will be with a blank workspace. So for the next thing we need to do is create our main file, so if we hit new file here, and we want a file, and we want a C++ source, so click that, hit go, C++, hit next, file name, click your ellipsis box here, and we want to save this in, if you click browse for other folders, want to make sure we save this into the right place, so yeah, we want to save this in Penjin document programming Penjin example. So call that underscore main.cpp and hit save. And we want to add file to the active project, and we want to include that in debug and release targets. So if we hit finish, you can see there's an arrow appearing in the example, and in our project management side tab we can see that it's been added to the sources. So if you double click that, well, it was already open, sorry. Just a side note, you can hit F2 to hide that bottom bar to give you a bit more editing space. And right, we should start off with our Penjin project. So example Penjin project. Okay. Well, what am I doing? I'm doing a mix of commenting styles. Okay, so if we include example what should we call it? Penjin example.h. Yeah, we've still got to create this, so have to make this later. Okay. Right, so in your main file you need a main function, so int main int argc pointer argv. So yeah, this allows you to do command line arguments with your program. What this is the number of arguments passed, this variable here, and this is the character strings passed in as well. So you need to process that yourself, and you can, you know, do different program operation based on those arguments. But that's beyond the scope of what we're doing right now, so we'll just carry on for now. I'd just like to say, if you do feel that I am going too quickly, please feel free to get in touch, ask me questions. I really don't mind. If I can explain any better, I will do. But for the sake of the video, I want to just get on with things. And I think it's good if you're left thinking, oh well, that's unclear, because it's good to ask questions, because it keeps you interested. That's my theory anyway, and also because I don't want to bore you to tears over explaining things. So yeah, basically that's how we're going to tackle it. So anyway, to carry on, we'll create an engine object, and engine is a class within Penjin. It's a sort of a template class that you have to customize. A base class is the better term, and we're going to create an object called game, and we'll set it to null. We need an error handler again, which is a class in, not an error handler, an error handler, which is a class in Penjin, and we need to create the game object. So game equals new, and it will be new Penjin example, which will be our customized version of the engine class. So there you go. From here, let's report some things out to the console. So cout error dot get error string, and where are we getting the error string from? We're getting it from the game object. So game arg handler argc argv. Okay, so this passes it to Penjin's argument handler, which you can customize. I think I've got some basic command line arguments as default there to set full screen and things like that, but you can customize more by overriding that function. So yeah, from there we can carry on, and let's report some other things. So error dot get error string, and what are we getting the error string from? We're getting it from game Penjin init, which is basic program setup. So this will actually tell you if there's anything gone wrong with the init function. So there you go. From the initialization, we can actually enter our game loop. So a simple game loop is to do an infinite loop until Penjin says otherwise. So again, we get the game object, and we do the state loop, and just terminate that while. And what that does is it just keeps repeating the state loop function, which is your input handling, your display, and your update, and it just keeps repeating that until state loop returns false. If it returns false, it drops out, and then we need to tidy up. So tidying up. Oh dear, cannot type butterfingers. So yeah, tidying up, we need to check if a game object still exists, and then we need to delete that object, and don't really need to do that because it's going to just drop out, but you know, it's good to get into the habit. Then you'll automatically be typing game equals null and tidying up your pointers, so you can check if they exist and stuff. Then we can say goodbye. What am I doing? Error dot get and a string, and we will just do a simple Penjin goodbye. And with everything done, we can tidy up SDL as well, so SDL quit, and we can return 0, which means program exited correctly. Program termination. Okay. What else? I'm just going to copy paste this. Penjin shutdown to show that we're tidying up, but to be honest, we're not doing too much. So, but anyway, yeah, there you go. There's your simple main function to access a Penjin game state loop. So there you go. Next thing we need to do is obviously create this Penjin example. So let's save that as we are, and we need to add a new class. Okay, class name will be Penjin example, no arguments, and it does inherit another class. It inherits engine, and this must be some sort of OCD thing, but I like to change this so it says with the what you call it, the quotation marks when it's not a system include, but you know, you don't have to do this. Header and implementation shall be in the same folder, and we want it in, I think that's the right, yeah, we want it in this directory here. So hit create and add it to the project, to all targets. And here we go, we have Penjin example.h. Okay, so we've used a couple of things, and we should add them to the project as well. We've used engine, so if we add files and we go to Penjin base and engine, the H and the CPP. Okay, we've also used the error handler, so add files, Penjin base, error handler. Yeah, you can start typing the file name and it will jump down. So error handler, double click that and add that to the project. So yeah, we started adding some of the Penjin base components that we need to actually run the project as well. So let's carry on. Okay, what do we need? Well, your Penjin example class is the overrided class of the engine class in Penjin, and it has a constructor, destructor, and we want to do an init function for it. So if you do virtual, because we're overriding the internal init function, Penjin errors, because we want to return error status from that, and we want to do init. So we need to override the init function. We also need to do state management. So if we do virtual void state management. Okay, so that's what we need to do in our customized engine, and you want these in the public scope. So with the H, the header file done, we should go to the CPP. And in the CPP we will fill out those functions. So okay, go to the CPP file, and in the constructor you want to set the application name. To set the application name, it is Penjin : and you can see Code Blocks has done some autocomplete for us. Set application name. Okay. And I'm just going to have to pause this video here. Apologies, because I'm getting a phone call. So let me just pause this video. Okay, yes, we got the set application name function. So let's set the application name to something like, well, we'll make it simple, Penjin example. Okay, so finish that with a semicolon. What else do we need? We should create an init function. So Penjin errors, Penjin example, init. And what do we need to do in the init? We need to set the initial game state, so that is set initial state. Normally in a game you would want to go to the title screen, so state title. Fair enough. What else should we do in the init function? We should set a graphics resolution, so graphics set resolution. You can either do this, which will sort of guess an optimal resolution, or you can set it to something you know will work. So if, for example, you want to do some Pandora coding, you would set that to 800 480, and it will run on in 800 by 480 on the desktop, and also on the Pandora. And to actually apply that resolution, you need to return graphics reset screen. So that sets the resolution to prepare for the actual screen setting, and then reset screen actually applies that resolution and gets the screen ready to start displaying stuff. What else did we need in our Penjin example class? We needed the state management, didn't we? So okay, so we do void Penjin example state management. There we go. And in the state management, we actually need to check which state will be next, and create the new state as needed. So check which is next state. So to do that, we want a uint next equals state get next state. So that tells we get the next state ID from the state itself, and we can use that to check which state to set up next. So let's see, if a state exists, delete that state, delete state, state equals null. There you go. So with the state deleted, we need to actually create a new state. So if next is equivalent to state base, then we just create the base state. So state equals new base state, which shouldn't really happen. If it happens, something went wrong really, but we check that case just to be safe more than anything. Check if the title screen state is triggered. State title state equals new state title. Otherwise, else, if none of the states are triggered, basically there's been an error, and we will error handler get error string for Penjin undefined state. Okay. So yeah, if the correct state hasn't been triggered, we print out the error that there's an undefined state that's trying to be triggered, and then we exit, because if the undefined state's triggered, we can't really do anything useful. So copy that there, we exit and return that return code. There we go. So that's the state management done. What else do we need to do now? That's the Penjin example. The actual example application is done. We just need to start doing the state title. So again, we want to add a class, a new class. We will call that state title. Same folder, that same folder will be the example. Okay, and yep, so create that. Yes, want to add it to the project. Okay, you know the deal now. So our state title, it needs an init function, so virtual void init. What else does it need? It needs a render function, so virtual void render. It needs virtual void update for physics type operations, and virtual void user input for input handling. What else will we do? Well, for the purposes of this tutorial, we'll keep it very simple. We will do class rectangle, and yeah, we'll just do that for now. This is a forward class declaration. Basically, it prepares the compiler that we will use a rectangle class, but at the moment we're not going to provide the full header for that class and tell the compiler exactly what it is. So yeah, we will do that now. We will do rectangle pointer rect, and this is our rectangle object, but as I say, the compiler doesn't actually know exactly what a rectangle is right now because there's no header included. We've just forward declared it, so rectangle object. Okay, so with that done, let's go on to the state title CPP. Righto, and yeah, for the state title CPP, we should actually create our rectangle. So if we do rect equals new rectangle, oh dear, cannot type rectangle, and as I said, the compiler doesn't yet know what a rectangle is, so now here in the CPP we can do hash include rectangle.h. So that is Penjin's rectangle object that knows how to draw rectangles and display them and so forth. Because we've done, sorry, do a rect equals null there as well for pointer checking, and we can just delete rect in the destructor there. So there you go, you've got your dynamically created rectangle object, and you're deleting it and tidying up and so forth there. We have an init function, so we need to set that up there. So void state title init. In the init function, what will we do? Well, we will set up the rectangle dimensions. So set dimensions. What shall we set that to? Well, if we've got an 800 by 480 display, let's go for something like, I don't know, 400 by 100, just to just for the tutorial sake, really, just so we can get something on the screen, can set the position of the rectangle, and again let's do 30, 40, purely for example's sake. What colour do we want the rectangle? We will set the colour should be right, but why isn't it coming up? Anyway, I think it's set colour like that. Let's go for blue. So yeah, Penjin has some predefined colours that you can just call like that. So yeah, we've set up a rectangle object at that position there, 30, 40, those dimensions in that colour. So to actually draw that is very simple. We just go void state title render. So we've got the render function there, and we just do rect pointer in direction there and render. We just call that render function, and that object is already set up to draw with those values. We'll create our update function, even though for this tutorial we're not going to use it. Sorry, it's a class, so you need to do state title : just to indicate it is part of the state title class. And what else? We have a void state title user input. Okay, so the user input, what shall we do? We will call input update, and we will check if the crossbox has been pressed so that the program will close down properly. So if input is quit, yep, it's quit, there you go. Then we do nullify state. Nullify state is just basically it shuts this state down tidily, then causes the program to quit. So that's what we want to do. And then input reset keys. There you go. Okay, so that's our title state done. With that done, we should basically set up the state lists so that we can come on, brain into gear, so that we can get the states changing properly in the project. Okay, so that's what we need to do. Right, come on. New file, header file, and you want to call this user states with their lowercase u, user states.h to all targets. Hit finish. Yeah, you need to set the full file name. In example, save, okay, finish, there you go. So we've got a user states, and here you want to create an enum. So enum state underscore modes, and state title equals 2. And you would add, if you had more game states in your game, you would add like state game over equal. Well, you don't have to set the numbers after that in an enum; it automatically enumerates from there. But you would set the other states after that. So you'd just put state game over, state high score, and so forth. In any case, after the enum there, you need to include, so hash include, well, the state for that identifier, so state title.h. So that is the identifier to switch the state, and that is the state itself. So there we go, that's the state list done. Basically, this is your example project ready. One other thing you can do is if you need to, depending on what you're doing, you might want to clear the screen. So graphics, clear screen. You can set the clear color. Well, you may not want to set it every single display, so you could do that in the init function. So if you do graphics, set clear color, and set that to red, we're going to have a horribly garish red with a blue rectangle display. So yeah, like I said, that should be everything. We may need to include some more things into the project. Well, we need a rectangle, so if we add files and we go Penjin base rectangle, again you need the header and the CPP. Okay. What else do we need? Right, we need to set up the project file as well. So if we go project and build options, and for the debug and release, actually we can do it here. You need Penjin SDL, not Penjin, Penjin SDL. You need what else do we need? Platform PC. We need Linux. Okay, and for the debug specific, you would put underscore debug. I cannot type today, I do apologise. And that should set that up at least. Search directories we need to add for the compiler. What do we need to add? We need to add // just dot. Oh, I apologise, that alarm's going off outside if you can hear that. Let's just try and carry on. And you need to add the Penjin base directory, which we've set up the global variable, so you can do $brackets hash Penjin. There we go. So that should hopefully be everything. We probably have to fix a few things, so let's rebuild project. Don't annoy me again. Here we go, and include the version header. I'm going to get rid of this versioning thing. In fact, I already got rid of it in Penjin 2. It doesn't make sense because we're using SVN and so forth for versioning. So in any case, at the moment with Penjin 1 you have to go to auto versioning. This is why I said to install the contrib plugins in the package manager tutorial. Configure the project for example for auto versioning, press yes, and basically don't worry about it and just hit accept, and then you'll have a versioning H file in the project, so we can try and rebuild that again, and at least it won't get a hiccup on that. State title. Right, why is that complaining about state title? Penjin example. Penjin example including engine H. What have I missed? Why is that complaining about state title? Let me have a look on my tutorial notes here that to help me do this video tutorial. State title. Right, so my game. I think it is because Penjin states I need that included. So hopefully, no. What's it saying? State title to base state. Why can't you? I'm sure we inherited this, but apparently not. Okay, so class state title, public base state. That's what was missing.
Perfect,
I do apologise.
Anyway,
At least we got there in the end. So as you can see, it's rebuilding now. And what have we here? Okay, so yeah, we forgot to include Penjin states. Okay, so with Penjin states there, it should know what base state is and so forth. So try that again. Okay. Yeah, we need to include the Penjin header, base state, and simple joy. So go to Penjin base, and let's select those files. So where are we? Penjin H and CPP, and also let's see, base state CPP and the H, and there you go, simple joy, H and CPP. So open those, press OK. Because we've added the simple joy, we'll also need the key mapping headers and CPP. So if you select all of these using Shift, you can mark the start and end point, and with the control button you can select additional, so add sound as well. Save everything, and let's build that again. And oh, we're getting a bit further. Ooh. Okay, now what's it complaining at? SDL map RGB fill rect. So this is our linking. So if we go to build options and yep, linker settings, we need to add the STL library, so add STL, okay, add STL image, okay, add STL mixer, right, try again because I managed to exit out of that by accident. STL mixer and hit OK. STL, what else do we need? STL TTF, yeah. Okay. Right. So I think that's it. So hit OK, and that should get rid of those errors because now I'll be able to find those. Okay, we need the graphics component, so add the files there in Penjin base and gfx.cppnh. Okay, I also know we'll need glyphs, so select those as well. What else will we need? We will need the text CPP&H, so open those. Okay, and let's try and get a bit further. So there you go, it's compiling graphics, glyph, text, and we've still got an error, so what's missing there? Random. So we need to add the random class as well. So if we go to add files, and Penjin base, and add random.cpp, random.h. So select those, open, okay, debug and release, okay. Hopefully we're okay now. Who knows? Let's save and let's see if that works anyway. String utility, okay, so same deal again. Just add string utility CPP&H. Okay, what else we got? Variable set variable. So add the files, Penjin base, and the variable H and CPP. Okay. Okay. So yeah, the variable class, I actually just save that and build. The variable class I actually added so you could pass variables between states, but it's something I'll probably improve in the future. Timer, we need the timer added, so you know the drill by now, just add timer, CPP and H. Okay. Oh, still not there. Color, image, parser. What else do we need? Vector 2DF. So let's try and add those files now, and I think we're nearly there. So color, image, parser, and I'm going to add all of these vector classes because we, you know, at some point, oh, not that one, not the vector 3D, that's an old class, it should be removed really. Yeah, all the 3D vectors as well, because at some point we will use them. It should probably be in every class, and that's not letting me do that because MMU hack is select for some reason. So yeah, deselect MMU hack and press OK, and here we go. building. Ah, it's still rotozoom's missing. So that's again, that's a library problem. Text doc. So yeah, we've got a couple of missing files and a missing library. So if we go to project, build options, linker settings, and we need to add SDL graphics here. So SDL underscore graphics. Then it can find that library. So yeah, we're using the standard SDL libraries. Okay. What else did we need to do? We needed to add text doc. So add files, Penjin base, and you can type text to get there, but text doc, CPP and H, add those. And we need the fixed point library. So if you go to Penjin base and Trenki, thank you very much Trenki for these awesome classes. Just add all of these here, the vector math and the fixed point classes. And what else? Oh yeah, and I've made my own fixed point additions to Trenki's fixed point namespace, so add those in as well. And I think yes, we've actually managed to finish building the project. So let's run that. And there you go, nothing too exciting. Red background and a blue rectangle with Penjin example version 1.0a debug. And oh, I seem to have lost that window. But there you go. That's basically your example finished. So thank you very much for joining me, and hopefully see you next time. Bye!